Okay, hi everyone. I hope this video finds you well. So today we are going to talk about the Getline method, the stream manipulators, and the Printf method. So in this lab, the first thing we are going to see is the extraction operator, something you have used before, and it's used to put the value you get from the user into the variable you defined in your code. So as you know, with the extraction operator, you always consider the spaces, the white space, the tabs, the new line as terminating the value being extracted. So if, for example, you entered your first name, as you can see, there is a space in here. It only takes first because this space is considered the interruption or corruption signal that corrupts everything after that. So it takes only the first part. Now that is also true for the tabs and for the new line, the enter you press. So if we are asking the user to get to enter the full name like this, so string full name, then cout enter full name, the user tries to enter the full name. So the user enters first, then last. When you enter what's stored in the full name, you see only first, and you don't see the last name. Now, how can we fix that? To fix that, we are going to use Getline. So now, create a project. You know how to do that already. Call it something meaningful. So in this lab, from this point on, comment what you have and do the next code and so on. So everything you do, comment it and start working on the next code because you're working on plenty of codes in this lab. So just a reminder that when we include something, you have two types of including, either the quoted form or the angle bracket form. The angle bracket search for the file or for the library in the designated folder of C++ base. The quoted search in the current directory where your project is in. So after you try a piece of code, go ahead, build the program, and think about what's happening when you build the program. Think about the building process. When you try to run your program, think about the loading process, and so on. Okay? So every part you're doing, build it, run it, think about what's happening, and then after you're done, comment it to start the next one below. Okay. So now go change the code in the main function to this. So copy this code and put it in your Visual Studio. So I'm going to do that too. I'm going to this slide, copy everything in here and put it in my Visual Studio. I put it in here. Just make sure that you have system pose and you have using namespace std there because we don't want to use std cout all the time, std cin and so on. So the compiler gets to know that cout, cin, and these kind of things are from the standard libraries. So try to run your code. Now, after you run your code, it's going to ask you to enter your full name. I'm going to enter my full name and you do yours. Now, my name is Ehab. I should see the full name. Instead, I just see Ehab, just the first name. Now, my goal in this lecture is to fix that. How? Let's go to the next step. The next slide says few things that I just mentioned, that you must include string library if you want a string. So if you're using string, it's always preferred that you include the string library. Sometimes, or most of the time, it's not going to work if it's used in a function other than main, or if it's used with pointers and these kind of things. So these are advanced stuff, but from now on, always include the string library, because we are going to use strings. Now, it may work like it just did in my program if I use it for simple things in main and so on. So I included the string library just to make sure that you include that. We are having using namespace std because we don't want to do std cout, std cin, and blah blah blah. For all these things, the compiler gets to know that everything I don't recognize, like if I see cout for the first time, I can go to the standard libraries mentioned above to look for it. And cout goes, oh, it's std from the standard libraries. What standard libraries do I have above? It goes for this iostream first, finds the cout, and so on. So you build and run the code. Make sure that you know what to do when it asks you to enter something, when you see the first name. So cin looks for a string. You give it a string, but it's not working. It's just giving you the first name. How could we fix this? Now, we will fix this with the getline function. Now, to get the entire line from the cin, we would use the getline function. It gets the full line from the cin, from the user. So it takes the stream cin as the first argument, and your variable, the one you store into, as the second argument. So what we are going to do right now is going to change this code where we get this line, where we get the user's input, and we use getline. So getline, give it cin and comma full name. Now let's try to see what's in the full name. So I'll just run my code, enter my full name, and see if that prints my full name or not. So yes, it did. So it prints the full thing. Why? Because it gets the whole line from the username. No matter how many spaces you have, no matter how many tabs you have, it stops only when you hit a new line. Or the inner, actually, because the inner is working as the interrupting signal. So if you want to know more about the getline function, here is the description in the c++.com/references. So there are several good online resources that can help you find out about a library or a certain function in a library. This is one of them. So you can get to see what the getline does. I just showed you a demonstration of how to use it, and this is the thing that you need for now. So sometimes it's useful to get the entire line. You don't need to use getline if you have if you're asking the user for just one input or one value input, like a number. Give me a number. Then cin is better, and cin is faster actually. If you're looking for speed, cin is faster than getline if you have a big code. So here it is. We changed this line in the code, and we built and ran our code, and eventually we got the full name. So now let's move to the stream manipulators. So the stream manipulators is basically a symbol or a function that is used by placing it on the right side of the insertion operator. You used one of them, right? End line. That end line is a stream manipulators that enters or puts a new line in your code, or sorry, in your output. Puts a new line in your output. So basically, end line is actually a stream manipulator. So we have parameterized string manipulators that are found in the IO_manip library, input-output manipulators library. Those are parameterized string manipulators. Looks like a function call. It has one or more parameters, like setWidth. SetWidth is basically building in kind of imaginary field of this certain width, so you can fit 10 characters, and it's by default right aligned. So it's going, if I write my name, it's going to put it in here and leave those spaces because it's by default right aligned, and those are spaces. So if you want to make it left, you can use another string manipulator that is not parameterized, and it's called left. And we are going to see how we will use that together. So you can set hello right aligned using setWidth and leave 5 spaces before. Now you can set the width you want. Now, the way the setWidth work is the following. If the number of letters, the number of characters in this output, hello, is less than this number, so we have 5 and we have an imaginary field, you can think of it this way, fits for 10 characters. So we have 5 out of 10 used and 5 spaces. 5 spaces, right? And where you will find the hello, you will find it to the right of the imaginary field, right aligned. Like this. Leave 5 spaces, then the hello is gonna show. So setWidth, the purpose of the setWidth is basically it's a parameterized string manipulator that performs the sum task of the member function width. So basically you can use the same with width. But we are using setWidth for now. So hello and 5 spaces left if it's 10. If that is 7 and this is 5, then only 2 spaces left, not 5, and so on. But if we have, for example, here 3 and we have 5 in here, then the setWidth is not going to affect anything, and it's as if it's not even there. And the hello is going to be written here. Okay, we have another parameterized function. It's called setPrecision. It sets the number of significant digits. And now for this one, for the setPrecision, it comes with a helper function, or a helper string manipulator, not function. So basically, if you use setPrecision without the helper string manipulator, it's going to set the number of significant digits in the whole number, like this. What is the significant digit? That is rounded up and becomes 6. Now, if you used it with fixed, as you will see in the next few slides, then it only controls the number of significant digits after the point. So if it's alone, it controls the whole number, the whole thing. If it's with the helper string manipulator fixed, it controls only this part. So setPrecision 2 without fixed, again, the 2 significant digits. So leave this alone and round this up, right? Round this, so 5.6. So before talking about fixed, left, and all these kind of things, let's talk about what is sticky and what is not sticky string manipulators. So a sticky string manipulator permanently changes string behavior, and most of the string manipulators are actually sticky, except for one, the setW. set width. The set width function is the only non-sticky manipulator, or at least the only one you will see today. So let's talk about, let's have an example of a sticky string manipulator. So assuming that we did this part is we are printing 18, the 18 you know, the decimal 18. So it prints 18, but then I say, okay, I want when I use string manipulators, I use the insertion operator. Remember that a string manipulator comes to the right side of the insertion operator. So I say, okay, I need hex. And by the way, the std is present here because I'm not using using namespace std. If I'm using namespace std, I don't need these things, right? Okay, but then I said, okay, I want hex. So anything I enter right now in decimal, I want to see it in hex, in hexadecimal, and the hexadecimal is the base 16. So 19 is going to be converted to the 16 base to hexadecimal, and you'll see it as 13, which is basically 16 plus, that is representing the 16 plus 3, which is this one. 20, same thing. 16 plus 4, this is the 20. So this is a sticky manipulator because we didn't have to do it the std hex or hex for every number. We just did it once, and every number after that is going to be in base 16 in hexa until you set that flag off. So basically, if I want to see the non-sticky string manipulator, then this is a good example. I print the 18 prints, then I'm not using hex or anything, I'm just using set width, which is a sticky. Only works for the next input only. This is why I say non-sticky. Only works for on the next input only. As you can see, we have 2 letters in here, 2 characters, and we have imaginary field that fits for 4 characters. So this is going to take 2 places, like 19 and 2 spaces. So here is 2 spaces and the 19, and it's right aligned by default. Then we print the 20, and the 20 is printing as it is because remember, this is we're printing decimal. We didn't print hexa. Okay, here's some common stream flags. Fixed, which is the one I just said. Basically, this if this is said, the floating point numbers are printed in fixed point notations, and you will get to see that in the next few slides. As I said, if this is set, then set precision is going to control the number of digits after the decimal point. Scientific is going to show the double or the floating point numbers in scientific notation, the exponential notation. 1 digit only before the point, then a few digits after the points, then you would see E something like E12. And that means times 10 raised to the 12th power. So show point is going to show the decimal point no matter what. Even if you have an integer like 15, it's going to say 15.0. Show pose is going to show the positive or negative sign. So even if you have 15 and 15 is positive, you don't have to say it's positive because you know that. It's going to show you the positive. Right is setting the set width right aligned. Left is setting the set width to be left aligned. Show base is going to show you the base you're using, like if it's decimal numbers with like base 10, the one we use in real math, or the octal, base 8, binary, base 2, hexa, base 16, and so on. Uppercase is going to show the letters of the hexa, and you know the hexa is 0 to 9, A to F. So it's going to show A to F, those numbers in hexa, and by the way, the E in the scientific notation as upper cases. Flush, it's going to cause the output buffer to be flushed to the output device before processing proceeds. End line, something you used, it adds a new line and flushes the output buffer. Date, basically DEC, this is causes the integers to be printed in decimal. Octal, this is printing the integers in octal. Hex, the one we just used, print the integers in hex. Set base, parameterized manipulators, that takes either 10, 8, 16. Instead of using hex, you can use set based 16 inside the parentheses. Octal, instead of using oct, you can use 8. Internal numbers sign will be left justified. Bool alpha, it's going to show the result of the Boolean expression in alphabets, like either true or false. No bool alpha is going to show the true or false as 0 or 1. Okay, so now you have seen many string manipulators. Let's try the next. So the next few slides are going to ask you to do some things using those string manipulators, and you should achieve that. So for question number 1, print the number 5.678 while having 2 significant digits. 2 significant digits, I mean having 2 significant digits in the whole number, not 2 significant digits after the decimal point, because that is different. So how would you do that? Now, let's just take this as an example. We will do that with set precision without fixed, and we will give it the number, right? So that is going to show 5.7. Question number 2, print the number 77.89578 to exactly 3 decimal places. Now, when I say decimal places, I mean 3 significant digits after the decimal point. This is what I mean. Something like this. Now, to do that, now you need fixed. You need to use fixed, because this is what I asked for. I don't know how many numbers in here. So if you say set precision 5, that may work on this one, but it's not going to work if I added another 7 in here, or 1, or any other numbers, right? To control only this one, to answer the question correctly, you need to use fixed. Now, fixed either used before the set precision, like cout, then fixed, then set precision 3, then the number. That is okay. You used fixed either before or after the set precision. Now, those are sticky string manipulators. If you use them once, everything is going to be to 3 decimal places if you print out any other numbers, any other floating numbers. So this is the code for it. So print the number 100 with at least 10 spaces, something like that. Now, this is a little bit inaccurate. So if I say 10 spaces, now I mean 10 spaces for the imaginary field. The 3 of them is taken, so you have 7 in here. You have 7 spaces in here. So you do that with set width of 10, and then you get the 100. Print the number 100 with at least 10 characters with this exclamation point instead of the spaces. Now, this is something you haven't seen before, so let me answer this question for you. You need to use set fill and give it special character. Now, you either give it a letter like ABC or exclamation point, question point or question mark or any other thing. It's up to you, or up to the question actually. So set fill is going to fill those with this exclamation point. If I do set fill with space, then it's going to have them as a spaces. And again, if you do that, then everything else is going to be padded with the exclamation points. Then you have 10 and you have the 100. So print the number 56.9089 to as a dollar and cents. Now, this is a little bit trivial if you think about it. You just print this first, then you print this number to two significant decimal places, which is fixed precision with two numbers and fixed. So printed that first without the end line because I needed next to the number, then set precision to and fixed, then your number. So print the number 56 as dollar and cents with at least 5 places in front of the number. You just need to have set with above all this, right? So here it is, set with 10 numbers. Then this is the actual output. These are string manipulators. So this is affecting only this one. Okay, print the number but pad the number with zeros. You just need set fill and set width. So set width of 10, set fill of zeros, and that. So print the string Fred with 15 places pad with spaces. Okay, you can do that with set width. Print the number, the string Fred with at least 15 places, pad the spaces, left justified followed by the word Shaggy. So Fred is going to be within the 15 places imaginary field and left justified, then the word Shaggy. So left, set with 15, then Fred, this is the imaginary field, then Shaggy appears in here. So printing rows, row 1 is going to have this, having this in row 2, and 15 places for each number. So if that number is 5, as you can see, then we have 10 in here left. 6 in here, then 9 in here left, and so on. So that would be this. That would be this. As you can see in here, set with resets after it's being used. So right when set with 15, do that, okay, then waits for the next input. So set with affect only this one. Then you need to work on this one again to affect this one. Set with 15 affects this one, and so on. So this is the sticky versus non-sticky. Sticky is going to permanently be there until the next change. Non-sticky, like the set with, it's going to affect only the next input, like the 4 in this example. So always keep that in mind. So everything we have done with all the string manipulators, you can do that with Printf. You can do that actually with Printf function. So another way to control the output is using the C function called Printf. It is particularly useful for column data. So we are going to use that, and it uses, the Printf is using the percentage sign. So because it's from C, it is considered legacy and not used as often in C++. So some languages like Java adopted Printf, even because, you know, it's common among programmers, so it's always good to learn it. And it's used very much, especially if you don't memorize all these string manipulators we just talked about. So this printf function is formatting the output. And as you can see, it's in languages like Java, C#. Even though in Java, they prefer to use their own function that formats. But it's still, you can use printf the same way. So this printf is formatting specifiers are positional. The first one is going to take the text, and whenever you want to plug something in that text, you would use the percentage and the specifier that tells what is that thing. For decimals, you would use D. For float point numbers, you would use percentage F, and so on. So the second one is the second item in your data list. So let's take a look at this one. So here is what I'm saying. The first one is the text. And the text is going to have some things to plug in. So for example, this one is taking character. This one is taking another character. This one is taking integer. This one is taking floating point number, a string. Then this is a new line, you know, the new line. So where to put the things I want to plug in? After the comma. So A for the first one. 65, which is representing A in ASCII, goes to the next one. 99 is your decimal point number, and so on. So let's see. So these are the data list, starts after the first comma. And again, if you want to know more about the printf, and you can learn a lot about printf actually, you can go to c++.com/references/cst studio/printf. So the items to inject or to plug in this string. So these are the items. These are the items. So this is matching this one, and this is matching this one, and so on. So it's color coded, just to make sure that you understand what's going on. So the letter after the percentage point tells the printf what type to expect. For example, we have percentage %C, which is a spot for a character. So it expects a character in that place. So the type must match the data, must match. This one is a little bit tricky. You give it a number, but since a number can represent or is representing the characters, like in ASCII, it's going to convert the 65 to corresponding ASCII character, which is going to be like the A, and that is going to work like this one. So it prints the A. Now, why? Because 65 is the ASCII for A. Okay, here is the most common format specifier codes. Like percentage %D prints the next argument as signed decimal number, like this number. Percentage %F expecting a floating point number. Percentage %C printing the next as a character. Percentage %S expecting a string, like a text in double quotes. This is one letter in single quotes, or one special character in a single quotes, or one digit in a single quotes, or a number that represents a character in ASCII. Two percentage signs. Basically, this is the plain old run-of-the-mill percent sign is printed. It's going to print this. This is like if you want to show like 15%, then you would do %D, then %, right? So then you give, for example, 15 in printf, right? And this is in always in text. So that plugs the D in here, then shows 15%. Here's the full list of format specifiers, a lot of them. You need to read about a lot of them if you want to work on more. For now, we are just going to start with a few things. So add this code to your Visual Studio and run your code. You should get something like this. So basically, I'm just saying, okay, 19.77 in 10D, which is basically padding the D. Basically, the 10 percentage 10D is creating imaginary field with 10 places and expecting a decimal point number, or decimal number, which is integer. But you're giving that a floating point number, so it's corrupting the data. This is why you have corrupting value, garbage value, we call it. So about literals, you know in computer science, a literal is a notation for representing a fixed value in source code. So almost all programming languages have these literals, right? These atomic values. So if you have 19 or hello world in a text, basically those are literal values. So build and run your code as you go. And now you try those things. So the first one prints characters A, and 65 is also representing a character and you're expecting a character. So A. So try all these and notice what is going on. So basically this one is taking the year, which is 1977. This one is padding with spaces. The year. This is padding with zeros. And this is how actually they pad with zeros. So you're expecting an integer. This is the part where you get the integer. 10 places for the imaginary field, like set width. And 0 is your padding. Blanks, so padding with blanks. 4.2, this is basically printing 2 decimal point, and the 4 is for the imaginary field that will show only 4. It's like set width with 4. Imaginary field with 4 places. And 2 is how many significant digits after the decimal point. So that prints 3.14. And so on. So you try all these and see the effect. So again, Printf can be a powerful tool. It allows the programmer a great deal of control. You just need to use the percentage and follow that with a specifier like percentage %d expects an integer, percentage if expects a floating point number, and so on. So before you leave, as I said, you should have commented all the codes that you have done and ran. Make sure that everything is working perfectly. Now, with the last thing in there as this, upload the CPP file to the assignment page on Canvas. That's it. Have a great day. See you in the next one.